Inheritance and polymorphism are two Java features used to extend the behavior of a class in case of inheritance or add new variations to existing behavior in case of polymorphism. In practice, you are using inheritance when you use the extends keyword, where in this case we are extending the behavior of an animal class through a human class, while polymorphism happens in two cases. First, when you override a method from the parent class, that means changing a behavior, and second, when you create a method with the same name as an existing one, but with different parameters, that means adding variation to a behavior. Now let's see this in practice. I have in my project a resource server class that when instantiated provides a getResource method that upon invocation makes a HTTP request and returns a JSON representation of a resource. But if this class is used to make multiple requests to a single resource, then each one will result in a new HTTP request to the server. So, to avoid nuking the server with requests, I want to implement a simple in-memory cache strategy in this class, where inheritance will allow us to extend the resource server class to then create a cached resource server class where we can add the cache feature, while with polymorphism, we will be able to intercept any call to the parent's getResource method and use of overloading to add a new option such as cache refresh. We begin by instantiating our cached resource server that we will implement soon, make a call to getResource method and check that the response has the ID we expect. Also in this case, no cache shall be used. We will create later this getLastCached method that will return the last element queried from the cache. If no cache was used, it returns null. Then we make a second call, which shall be using the cache, and check the last element query from the cache. If both are the same, then the cache is working. Now let's get down to the implementation. First, let's create our cached resource server class, and with the power of inheritance, extends from our existing resource server class. We will be using a hash map to store the responses from the server and a string to keep track of the last item queried from the cache to help in the verifications in the tests we wrote before. Now comes the polymorphism part, where we will override the getResource method from our parent class, and within this method we will also make a request, but with another cache logic. Let's focus on the method now. First thing I need is to create a unique key to identify a cache entry. Then, if our cache contains the key I created, we return the cached content. Otherwise, we call the parent's getResource method to make the HTTP request. It is important to note that just because we are overriding a method, that does not mean we are erasing the parent's class implementation. Within an overridden method, we can add our custom logic and call the parent's implementation to run the original logic. For this, we use the super keyword that is a reference to our parent class. Then we just call the getResource method. Finally, we put the resource in the cache and return it. The last detail here is to keep track of when the cache is used. So every time this method is called, we reset our last hit key field, and then, if the cache is used, we write the current key to it. If we get back to our tests, there is still this getLastCached method to implement. Back to our class, we add this method that checks if there is any value in the last hit key field. If no, then return null. If yes, this will return the last resource that got cached. Now with this method done, our test is ready to run and give us the green check. Let's add now the option to refresh a cached resource. We start with an instance of our class, getResource, and this shall not trigger the cache. But if you call it again, this will result in a cache hit. Now, if I don't want to use the cache, I will pass a flag as the second argument of the method, which we will implement later, and this should result in the cache not being used. Getting back to our getResource method, we will need to create another one, but with an extra parameter. Note that we don't use the override method when we have this refresh boolean now. This is one of the facets of polymorphism that is called method overloading, same name as the other getResource method, but with different parameters, aka a different signature. Since this method has to do the same thing as the previous one, but with some minor adjustments, we will be replicating the logic from the previous method here. Let's paste the body of the previous method, and now in the other getResource method, we will fill its empty body with a call to our new getResource method. This is not something related to inheritance or polymorphism, I'm just putting the code in the right place so I can reuse it instead of duplicating it. Also note that we pass false as an argument because this method should always be used in the cache. Now, back to our new method, we just need to add the cache invalidation logic. And that's it. If the current key has a cache associated with it and I want to refresh the cached content, then this flag will be reversed and this if will be ignored, resulting in a fresh content being put into cache. And if we get back to our test, everything works as expected.
Wait a minute!
There are still things to do. We solved the use case of dealing with a single resource, but there is another case that we haven't counted for. A collection. Now we have to deal with pagination and the amount of items presented per page. I left the source code below with further instructions about this task so you can implement it yourself. There will be 2 new test cases for you to fix, more use of method overloading and more use of method overriding, but no more inheritance because we already solved this one. I'll be getting myself a nice loaf of baguette while you finish this. When you are done, let me know in the comments below.